Good morning. Today we will discuss about that is how we can sort the array. Earlier in array we learned that how to display the forward data and how to display the reverse directional data of array. We also learned that how to search an element, how to find the maximum, that is first maximum, second maximum, third maximum, and all these things we learned. We calculate the average, we calculate the total, we calculate the count of the element in the array. Now we want to move towards how we can sort the data of array. For example, I have one array and that array is with the size, for example, 10 elements. Now randomly I have the elements, that is 43, 21, 45, 23, 65, 76, 44, 78, 54 and 48. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 data I have. Now I want to sort this data. It means before sorting the data, I just want to display this particular data. So very simple. Here you can just take the low, that is I equal to 0, I less than, that is the total size of your array, and then you can simply print each and every element by calling ARR of I. So your index will be run and you will be able to see the output. For example, here you can see that your data, that is 43, 21, 45, 23, 65, 76, 44, 78, 54 and 48. All this data are displayed over here. Now my task is very simple. I want to sort this data. So the question is how we can sort the data. So let me show the same thing on the paper first. For example, suppose if you want to sort the data, the data is that is on the screen, and that is 43. Then we have 21. Then we have 45, 23, 65, 76, 44, 78, 54 and 48. Now I just want to sort the data. Then what is the technique? Technique is very simple. Here what we can do, we can just take first element, right? So your first element is 43. You can just compare and check. So your one data will be matched with all this data, right? So what I want to do, I want to just check, is 43 is greater than 21? If yes, then I just want to swap these two numbers, right? So in first iteration what happened, see, is 43 is greater than 21? Yes, it is. So what happened in this particular case, your output will become like this, 21 then 43. Then again your data will be same, that is 65, 76, 44, 78, 54 and 48. Now your first element is still a 21, right? Now you can match. Is 21 is greater than 43? No. Then no need to swap. Is 21 is greater than 45? No. Is 21 is greater than 23? No. So 21 is greater than any other element? No. So you can say that this is the final position. It means this element is locked. This will be the first element and that will be the 21. Now you can take your another number and that will be 43. Now is 43 is greater than 45? No. Is 43 is greater than 23? Yes, it is greater than the 23. So what we can do over here, this is a locked element, so it will be 21. Is 43 is greater than 23? Yes. If it is yes, then you can simply swap these two numbers. So how we can swap? Simple. You can write 23, 45 and 43 over here. The rest numbers will be as it is. Right. Now you can check your second number. This is already locked element, that is 21. Now your second element is 23. Is 23 is greater than any other number? If yes, then just to simply swap this. If no, then this will be also locked element. Now the third number is 45. So is 45 is greater than 43? Yes, 45 is greater than 43. Then you can simply swap these two numbers, right? So what we can do in this particular case, very simple. You have the output that will be 21, 23. These are the locked element. This will be the two element. Now your 43 and 45 will be replaced. That is 43 and then 45, 65, 76, 44, 78, 54 and 48. Right. Now you can just check. See, let me close this. Now you can just check. Is these two are locked? Is 43 is greater than any other number? No. Then you can lock your number, that is 43. Right. Now your 21, 23 and 43 is fine. Now you can take another number, that is 45. Is 45 is greater than 65? No. Is 45 is greater than 76? No. Is 45 is greater than 44? Yes. Then you can simply swap these two numbers. So what happened? Your 44 will be available over here and your 65, 76 at the same position. Your 45 will come over here. That will be 45, 78, 54 and 48. Now your 44 will be locked because no, 44 is not greater than the any other number in the list, and that is the reason why 44 will be locked. So now your data will be, that will be 21, 23, 43, 44. These are the four locked position. Now is 65 is greater than 76? No. Is 65 is greater than 45? Yes. Then what happened? Your 65 and 45 will be swapped. So you will get here 45, then 76, then 65, then again 78, 54 and 48. Now you can check, is 45 is greater than any other number in the list? If yes, then you can simply swap. If no, then you can lock that particular position and that will be your 45. Now you can move ahead, right? And you can take the number that will be 76. So is 76 is greater than 65? Yes, definitely 76 is greater than 65. So what happened in this particular case? Your value will be replaced. That is 44 up to 45 it is locked. Now 76 and 65 will be replaced. So 65 and 76. Is 76 is greater than 78? Right? Again, you can simply replace this value. Now your instead of 76 your value becomes 65. So now you can compare your 65. Is 65 is greater than 76? No. Is 65 is greater than 78? No. Is 65 is greater than 54? Yes. Then you can simply. So what happened in this particular case? Your this two numbers, that is 65 and 54 will be swapped. So 54, 76, 78, 65 and 48. Now you can move ahead and you can check what happened. Still our 1, 2, 3, 4, 5 element are fixed. Sixth element is not fixed yet, right? So sixth element is not fixed yet. Is 54 is greater than 76? No. Is 54 is greater than 78? No. Is 54 is greater than 65? No. Is 54 is greater than 48? Yes. Then you can swap this two number, that is 54 and 48. So you will get 48 over here. Then your 76, 78 and 65 at the same position and you will get the 54 over here. The same way you can do this. Now see, the 48 is locked over here. So your sixth element is locked. Now you can move for the seventh element and that will be 76. Is 76 is greater than 78? No. Is 76 is greater than 65? Yes. Then you can simply swap these two numbers, that will be 76 and 65. So what will be your output? That will be, these are the locked numbers we all knows very well, right? That will be 44, 45 and here 48. Now 76 and 65 will be swapped. So 65, 78, 76 and 54. Now is the 65 is greater than the 54? Yes. 65 is greater than 78? No. 65 greater than 76? No. 65 greater than 54? Yes. So what happened? Your number will be 21, 23, 44, 43, 44, 45, 48. Now 65 and 54 will be swapped. So you will get 54, then 78, 76 and 65 over here. Now your 54 will be locked. Why? Because 54 is not greater than the any other number after that number. Now all this number are fine. It means up to 54 it is fine. Now I need to check. Is 78 is greater than 76? If yes, then you can write 76 over here, then 78 and then 65. Is 76 is greater than 65? Yes. Then you can simply swap these two numbers and that will be 65, 78 and 76. And now your eighth number 65 will be locked over here. After that, is 78 is greater than 76? Yes. So you will get 76 and then you will get the 78. So your ninth number and 10th number will be locked. And now if you look carefully in your data, then it is in a sorted order. That is 21, 23, 43, 44, 45, 48, 54, 65, 76 and 78. And these are the steps. What I did nothing. I just taken the first number, then compare with all other numbers. If any other number is greater than this number, then I just simply swap that two numbers, right? So this is the ultimate logic. Now suppose if you think that, sir, how can I write the same thing in programming? How can I match all these things in programming? So it is very simple. You just need to take your first number and then you need to compare with all other number. So how we can take the one number and we can compare it with the another number? So very simple. Here you can just take a loop, that is 4, I equal to 0, I less than 10, I plus plus. So your zeroth element will be, that will be, suppose if you are printing here ARR of 0, then it will be 43. So I will just simply match 43 with the other number. Now I am taking another loop, that is I plus 1. Why I plus 1? If I is 0, then I want number from 21 to this. If I is 1, it means if it is a 21 over here, then I want to match all this. What I did over here, I just logged every number. So once any number is finalized, I don't want to look all other conditions. I want to look in all these conditions only. So I'm just taking here, that is I plus 1, that is j equal to, and j will be run up to which number? Up to 10. Why? Because there are 10 elements are there. Now I just want to print every number so you people can get the idea, that is percentage d percentage d. Let me print here, that is ARR of I and ARR of j. So I'm just simply printing all these numbers. So I need a two loops, and that is the reason why I need the two variables I and j. Now whenever you print all these numbers, right, you people will be getting the proper idea what I am doing. See, I just come for the comparisons perspective. See, my I is what? That is first number, that will be 43, right? So I equal to 0, that will be 43. So 43, 21, 43, 45, 43, 23, 43, 65, 43, 76, 43, 44, 43, 78, 43, 54, 43, 48. It means 43 is working with all these numbers, that is 21, 45, 23. If you look carefully over here, then this is my I, and my I is 43 every time. Why? Because it is the first element. In the next line, my I will be 21. So here every time you will get the 21, 21, 21, 21, 21, right? Here you will get every time 45. So 45, 45. Your alternate number will be 45. Why? Because we are printing here I. Now, if my this I variable is greater than this number, then I want to swap the position, right? So what we can write over here, that is very simple. if ARR of I, it means ARR of I will be 0 first, that is 43. If it is greater than ARR of J, what is ARR of J and what is ARR of I, you know very well. See, here your I variable is this and J variable is this. Your I variable will become every time remain same. Why? Because for each I am running the J. Right. So if ARR of I greater than ARR of J, then I just want to print this. Otherwise, I don't want to print any numbers. Now you people will get the idea that a 43 is first time greater than the 21 and 43 is greater than the 23. None other than these two numbers, that is 21 and 23. None other than this numbers 43 is greater than. If you took the number that is 45, then the 45 is greater than the 23 and 45 is greater than the 44. Definitely 45 is greater than the 43 also, but I am running the loop up to I plus 1 and that is the reason why that number is skipped. So now what I need to do? I just need to swap the numbers if that numbers is greater than that particular number. So how we can do this? Here we will simply print the array so we can check that the number is replaced or not. So I am doing what? Temporary is equal to ARR of I. So what happens? See, the first number will be, that is 43. If 43 is greater than 21, then I will store 43 into temporary variable. Then I will just write ARR of I equal to ARR of J. So what is J? J will be 21. So your 21 will be stored instead of 43. And here we want the 43. So it is already there in the variable temporary. So we can write over here, that is ARR of J is equal to temporary. So using the third variable, we can swap the data. Once you swap the data, definitely we need to take the number here and that will be our temporary variable. Now, once you swap this data, you will be able to see that. See what happened. 21, 43, 45, 65. 65 is greater than the 45. 65 is greater than the 54 and 48. 21 is not greater than any number, but 43 is greater than the 23. 43 is not greater than the any number if you take the 43 at the third position. Now 45 is greater than the 44 and that is the reason why we will get the 44 after the 43. Let me print all this data. This is just a tracing display. If you don't print over here, then your actual array will be sorted. So now if you want to print your actual array, then you can simply write I equal to 0, I less than 10, I plus plus. I'm simply printing my actual array, that is ARR of I. So what happened in this particular case, you will be getting that 21, 23, 43, 44, 45, 48, 54, 65, 76 and 78. This is the exactly the same numbers that I trace on the paper. The same thing you can display over here if you just remove this. Right. If you just remove this, then you people will be able to see that this is a, after this loop, this is the sorted data and this is the tracing data. Right. So if you print over here the ARR of I, then you will be able to see that. See, if the number is greater than that number, then I'm simply replacing. So your 21 will be at the first position, then 43, then 43, then here 44 will be there, right? So 45 is greater than the 44, 65 is greater than the 45, 65 is greater than the 54 and 48, 76 is greater than the 65 and 54, then last 76 and 65, and at last 76, and you will get the 78. The same thing I did on the paper. If you look carefully, then what I did, see, the 21, 23, 43, 45, 48 is locked, so 48 is locked. So after that particular loop I am executing, right? And then 54, then 65, 76 and 78 I am getting. You can take it from the user also. So what I did is very simple. Before replacing, if you want to print this, then you can do like this. You can simply copy this and here you can print, that is, which is your I. So your I is, before running, your I is this, and after running your J, your I is changed, right? So first it was 43, but it is replaced with the 21. Then it is already a 43, right? And then it will replace with the 23. After that, 45 and all other numbers will be displayed. So you people will get the exact idea what will be your I. So your I will be, that is 43. Why here a 23 and all these numbers are not displaying? Simple. I just given the condition that if array of I is greater than the j, then and then replace this. And one of the biggest thing is over here is what? If you simply write over here, and that is if it is less than ARR of j, then you will get the data in descending order. See, that will be 78, 76, 65, 54, 48, 45, 44, 43, 23, 21. So you people will get the value in the reverse order, right? So your 21 value will be available at the last. And here not only I, but if you print ARR of I as well as ARR of j, then you will get the exact idea about this. That what happens, see, let me give the space, so you will get the idea that which number is matching with which number. So first number, and instead of less than, let me make it here greater than, so I will get the data that will be in ascending order. Now the clear cut difference is available over here, what I did and what is the value. See, 43 is greater than 21. Yes, then replace the 21 and 43. So here you can look into the second line, that is 21, 43, right? Now, is 43 is greater than any other number? No. So we just locked the 21 and 43. So both are locked. After that, what we did? We started with the 43. So 43, 45. So is 43 is, so 43, 45, 43, 65. Here every time my 23 number is displaying. Why? Because this is my I value, right? So if you are not displaying your I, then you will get the exact value over here. So you can simply remove this I, so you will get the exact j, and then you can compare the same on the paper. So but what happens, see, if the number is already greater than, then we simply swap that particular number, right? So your 21 and 23 will be swapped. After that, here if you look carefully, then what happens, see, 43, 45, then 65, right? So all these numbers, definitely my 43 is greater than the 23, so it will be also replaced, and as a result I'm getting the 23 over here. See, if you don't want to print this tracing, then it's fine. You can simply remove this. No need to print all these things. At last, you can simply print your array and your array will become sorted. See, right? And one of the good thing is what? If number is greater than, it means if 43 is greater than 21, then just swap the 43 and 21. But if 43 is not greater than 21, then I don't want to swap the numbers. But if it is less than, then I want to swap. It means if it is less than and then you want to swap, it means you want to sort the data in descending order. And as a result, you will get the 78, 76, 65, 54, 48, 45, 44, 43, 23 and 21. Suppose if you think that, sir, I don't want the numbers over here, I want to get print here 0. I want to get the number from the user and then I want to sort the data. Is it possible? Yes, it is possible. You can simply take the number from the user. So for that, you just need to write here ampersand ARR of I for scanf, right? So we will simply write here enter number. So we will ask to the user to enter the number. We will get the number from the user ampersand ARR of I, and definitely we will write this in a curly braces because we have the more than one statement in that it is required. So we will ask to the user how many numbers you want. So first we will ask to the user enter how many numbers you want. So now I don't want the 10 numbers. So I will just ask that percentage D ampersand N. And here you can get the variable that will be N. Instead of 10, you can write here 100. So now my array size is 100, but I will not go for up to 10, but I will go up to N. So how many numbers you want to store? I want to store the 15 numbers. So it will run up to n. Now wonderful thing is what? Instead of 10, here you can write n. Here instead of 10, you can write n. Here also instead of 10, you can write n. And now you can run your program and you will be able to see that. Suppose if you're writing 5, then which 5 number? 5 number is like this, then it will be sorted in the descending order 77, 67, 65, 43 and 23. And suppose if you say that sir I want to enter the 10 numbers, 15 numbers, so you can enter the any 15 numbers over here and you will get the exact results that you want, and that will be in a descending order. Why descending order? Because I use the less than. So I'm swapping in which situation? If I'm swapping in which situation? If the number is less than the next number, then swap this. Right? So is 43 is less than 21? No. So no need to swap. Is 43 is less than 45? Yes. Then simply swap this number. So what happened? Your 45 will become first and then 43. As a result, if you're writing here less than, so as a result, you will get the data in descending order. But if you write greater than, then you will get the data in ascending order. Suppose if you have 5 numbers, then you will get the data in ascending order 23, 65, 76, 78 and 98. Now suppose if you think that, sir, can we sort the character? Yes, you can sort the character also. For example, let me save this file as demo35.c. Now I want to sort the string. So is it possible to sort the string? Yes, definitely we can sort the string. So what we will do in this particular case, that instead of integer array, we will make it over here, that will be character array of 10 is equal to, and now I'm writing here that is Atmiya space uni, right? So there are 10 characters over here, that is Atmiya space uni. Space is a character. Now I will run this particular loop up to 10 times. I will run this particular loop up to 10 times. We will simply replace the character. Definitely we will run up to 10 times. Instead of percentage %d, I will print the character, right? And if the value is greater than, so based on the ASCII value, it will do this, right? So is the ASCII value of A is greater than the ASCII value of T? No. So it will not be replaced. But the ASCII value of space is less than the A. It means ASCII value of A is 97 and the ASCII value of space is 32. So is the ASCII value of A is greater than the space? Yes. So space will come first, right? So the same way we sort the data of integer, the same way we can sort the character also. So now, as a result, you people will be able to see that, see, the space is coming first, then A, there are two A in the string, that is A and A, I, there are two I's are there because Atmiya uni also contain the I, and Atmiya also contain the I. Then M, then N, then T, U, and Y. Why space is coming over here? Because I am printing the space. If you are not printing the space, then space will not come. Only first space will be there, and that this will be the this. So this is the way we can do with the sorting the character. So suppose if you think that, sir, I want to enter the string and I want to then simply sort the string. Is it possible? Yes, it is possible. Instead of this, that is character array is equal to, that is, this is the static string, right? But I don't want to define over here. I just want to make that the character of 100. Now I want to ask user to enter the string. So what we will do? Enter your name, and I want to sort the characters in name. So what we can do over here? We can use the scanf %s for string, and then we will simply get the ARR. Now instead of I less than 10, what we will do? We can write here until and unless ARR of I not equal to null. So what happened? The last character of every string will be null. So we can write here if j less than ARR of, it means if ARR of j not equal to null, up to that particular thing, you can run this. If ARR of I is greater than the ARR of j, then we can simply swap the character. And at last, we can print the same. So it is asking for the name. For the name is, for example, Parag. Now I am getting what? See, double A G P R. It is perfect. But why I'm getting other 5 characters? Very simple. Here, whenever you are printing, I'm running up to 10, and that is the reason why it giving me the output like this. So I need to write the condition over here that will be run up to ARR of I not equal to null. So you can sort your character array also. Suppose if I'm entering here, that is Parag, then it will give me that double AGPR. So this is the sorting of character, right? So you can do the sorting of character also. Now the benefit is what? You can write the Athmian. The output will be like this, double AIMTY. But remember students, if you are writing a space, that is Parag space Shukla, and if you press the enter, then the space will be truncated. After space, all the character will be truncated. The reason is what? Reason is very simple. Whenever you are giving a space, your %s cannot recognize the letter after %s. So what to do in this particular case? You can take the input from the user. So you can write here get s function. So what get s will do? Here you can get s, and what you want to get? We want to get the ARR. ARR is our array. So you can get the string from the user, get s of ARR. Now suppose if you write here Parag Shukla, then it will give you the proper output. So get s is used to get the line. So if you want to get the wall line, then you can write the get s. But what is the problem with get s? Whenever you press the enter, for example, suppose if you think that, sir, I want to sort the paragraph. Is it possible? Yes, it is possible. But if you want to write the paragraph, then definitely we need to write like this, hello all. Then I am writing comma and then enter. Then what happened? See, your get s will not work properly. Why? Because whenever you press enter, your get s will took the data. So instead of get s, so if your content is more than one line, if your content is more than one line, then you can use the scanf. Here in a %s, we can write the regular expression. It means we can write not symbol over here, and then we can write the dot. So it means until and unless not found the full stop, you can get the input from the user. So now if you run this particular case, for example, I'm writing hello all, and I'm just giving the comma. Enter is working properly. See, hello all. I hope you all are enjoying. Now I am giving enter, and I'm giving the name, that is Atmiya, and now I'm giving this full stop, right? So whenever you give the full stop, you will get the data, and now you will be able to see that these are the spaces, right? 1 2 3 4 5 6 7 spaces are there. There are 5 A are there in the string, then E, H, I, J, N, O. So now suppose if anybody asks you that find the frequency of the character, in the given paragraph, then it will be very easy for you guys to find the frequency of the character from the given string, right? And that you can do with the array. So remember student, what happened whenever you are taking array of character, it is treated as a string. Whenever you are taking array of character, it is treated as a string. So here you can simply do like this. Suppose if you think that sir, can we print the triangle of string using this? Yes, we can. For example, suppose if I am saving here, and that is demo36.c. Now, what I want to do, I want to print the triangle. So, is it possible? Yes, it is possible. Suppose if I am writing %s, then your string will be taken from the user. Now, you can write for I equal to 0, ARR of I not equal to null. So, what happened in this particular case? Your loop will run up to ARR of I not become null. Suppose if you are printing %c space ARR of I, then your array will be displayed via, it will contain space between each and every value. See, it is asking me for the name. I am writing here, that is C programming. Now what happens? See, it is displaying C space dash space P dash space R space O. It means it is extracting each and every character from the string. Now, once you are able to extract the character from the string, now it is very easy for us to print the triangle. So we can write here j equal to 0, j less than I, j plus plus, and now you can simply print your ARR of I, and then you can simply write here, that is put the line break. So now it will ask me to enter the name, and if I enter the Parag, then it will display like this. But what happened in this particular case, it is running up to less than I. So P is not giving over here. So we need to write like this, that is less than or equal to I. So whenever you write less than or equal to I, what happens is, suppose if you write Parag, then P-A-R-A-G, Parag is displaying. And this program is wonderful. Why? Because if you are writing C programming, then you will get the triangle like this, that is C programming. So it is very easy to deal with the string if you are managing the character array. So if you are working with the character array, it means that it will be treated as a string. We will look more and more into this particular thing, that is you can say string. So I will definitely take a whole lecture on string. Right now, this is just an introduction about the string. Why? Because I'm explaining the concept of character array. So character array is known as a string, and you can get the string. Suppose if you think that, sir, can we do the insert, delete, display, find, all these things with the array? Yes, you can do all these things with array. There are two applications of the linear data structure, because array is the linear data structure and it stores the value in the sequence. So there are two applications of the linear data structure, and that two application is known as a, one application is known as a LIFO, means last in first out. It is known as a stack also. Another application of the linear data structure is known as a FIFO, that is first in first out. it is known as a queue, right? So there are two applications of linear data structure. We have a wonderful example of the LIFO and FIFO. The example is, suppose if you look into the income tax written filed by any person, then the last income tax will become first, right? So it is known as a LIFO. And if you see a queue of any ticket booking, then it will be first in, first out. Suppose if you are staying into a line for booking of the ticket, then it will be first in, first out. So it is known as a queue, and this is known as a stack. Both are known as a linear data structure. And wonderful thing is what? We can manage the linear data structure using array. Now I want to show you guys what we can do with the stack. So very simple. Suppose if you want to insert the data into stack, then it is known as a, the wordings related to the stack is what? Suppose if you want to insert the data, then it is known as a push, right? So in a stack, insert is known as a push. Suppose if you want to delete the data, then in stack it is known as a pop. Suppose if you want to display the data, then definitely it is known as a display. Now suppose if you think that, sir, I want to find some data, that my data is available at which position, then in data structure it is known as a peep. So you can find your element at the nth position. Suppose if you think that, sir, I want to get the which element is available at the top, right? So if you want to find the top element in the stack, so suppose let me give you a best example, which is the last income tax file written by you. If I'm asking the question like this, then the last income tax written was in 2020, right? So this is known as a top. So which value is at the top of the stack? It is known as a peak in stack. Now suppose what I want to do, I want to take a simple array. So you can say that this is my array. Now what I want to do, whenever user says that, suppose you can say that this is the 0, 1, 2, 3. So this is my data structure, this is my array, right? Now suppose if anybody says that I want to enter the 10, then we will enter the 10 at the 0 position. Now suppose anybody says that I want to insert the 20, then we will insert the 20 at the second position. Now anybody says that 30, then we will enter the 30 at the third position. Now if anybody says that pick the element, then the last element that is available, that is, you can say the top of the stack is 30. So you will display the 30. Now which element is available at which position, that you can get from the 0, 1, 2 like this. Now if anybody says that I want to pop, it means I want to delete the data from array, then which position will be popped first? So last element will be popped first, so this element will be popped. So your 30 will be popped, so it will be removed from the stack. Now suppose if you insert the 40, then 40 will be inserted over here, right? Now suppose if you are entering 50, and suppose if you think that, sir, I want to pop the data, then your 50 will be popped first. It means your last element will be removed first. This is what the concept of stack. So how we can do this? Very simple. We can manage one variable, and that variable is top. Whenever we get the number, we will insert at the top position. So if we have a 3 element, then your top will become the 2. If we have 3 elements, then your top will become 2. Why? Because 0, 1 and 2. Suppose if we have a 3 data, that is 1, 2, 3. 3 data are there. So 0, 1 and 2. So your top will become 2. So whenever you insert the data first, that is at the first position, suppose if you want to insert, then your top will become the 0. So we will initialize our top variable with the -1. Why? Because whenever we insert the data, we will insert at the 0th position. So I will take one variable top and we will maintain the same. So let me show you the practical thing about this. It is very simple. So let me save this program as, that is, demo 37. Very easy to do the programming in, that is, to manage the stack. It is very simple. Suppose I don't want to directly push, pop and display. I want menu driven application I want to develop, right? So I'm writing here do, then you can write printf, then we can write here, that is 1 for push, then we can write second for pop, third for display, 4 for peep, 5 for pick, and 0 for exit. So pop means we will delete the element. 3, that will be, you can say, to display the element. 4, and that is for the peep, that is, you can say, to find the element. And 5th, that will be pick. It means it return the top element, which is the top element available in the our stack. And 0 for exit. Then we will ask to the user, that is /n, enter your choice. So whatever the user's choice is, based on the choice, we will manage our menu. So ampersand ch, definitely I need to take the variable, that is ampersand ch. This loop will run up to choice not equal to 0. First you can test this. You can simply run, build and run. Once it is run, you can check. If you are writing 1, then also your list will be repeatedly it should be displayed. Yes, it is displaying 2, 3, 4, 5. Everything is working on. If I am writing 0, then I will be exit from the program. So it is working properly. Now you can pass your choice into switch case. So what we can do over here? Simple. We can write case 1 for pushing the element. That is, you can say, to insert the data, we will write the case 1. So I want to insert the data first, and then I want to simply display the data, and that is the reason why I will use the case 3. So in case 1, what we will do? Simply, we will ask to the user, and that will be what? Enter how many elements you want to push. So how many elements you want to push? I want to push, for example, that is n element. So I will take here ampersand n. Definitely I need to declare the variable n. I need to declare the array. Maximum size is, for example, 100. I need to declare the top variable as we discussed on the paper, that we will declare the top with the -1. Now, how many numbers you want? So I want n numbers. So what we will do? We will just run our loop up to n. So we will write here I equal to 0, I less than n, I plus plus. So now we will get the value from the user, that enter any number. So whatever user enter, that we will store. Where we will store this number? We will store this number in one variable, that will be number. So definitely I need to declare the variable number. Now what we will do? See, whenever the user enter number, for example 10, then we will store the 10 into our array. But at which position we want to store the 10? So definitely we discuss on the paper that we will declare the top with -1, and whenever user enter any number, we will insert at the first at the 0 position, then at the 1 position, then at the second position, then at the third position. So we will manage our top variable. So we can write here ARR of top is equal to number. But what happened? Your top is -1. So we can write here, that is ARR of plus top. So it will be pre-increment. So what happened? ARR of 0 is equal to number. So at 0th position, my number will be stored. So once it is done, you can simply run your loop up to which? That is I equal to 0, I less than or equal to top. Why less than or equal top? Because top is -1. So if it has one element, then it will run up to 0 to 0. If it has two elements, then it will run up to 0 to 1. So less than or equal to top, we can simply print our variable value, that will be percentage D, and we will print ARR of I. So our index variable is top right now. So whenever you run this, definitely see what happened. I need to declare the variable that is I, because I am using the variable I in a for loop. Now manual driven application is this, so it will ask me what you want to do. I want to push. How many element you want to push? I want the 3 element. So what it will do? It will run up to n. So n will be 3. Right? So 3 element will be inserted 10, 20 and 30. Right? So now what will be your top? Your top will be 0, 1 and 2. Right? Now whenever you display this, you will getting the list that is 10, 20 and 30. Why? Because it will run up to top. Now suppose if you are writing 1 again, how many element you want to push? So I want to push again 5 element now, and that will be 40, 50, 60, 70 and 80. And now suppose if you display this, now it will display the 10, 20, 30, 40, 50, 60, 70, 80. So it means pushing is working properly. Number of elements, that is n. Suppose if you are writing now again 1, and if you are entering two numbers, that is for example 90 and 100, so your n become 2. So we cannot run up to n loop, we can run up to top. Why? Because top is incrementing every time whenever we get the element, right? So our list will be 10 to 100. Now I want to pop the element, and we all knows what we did. See, on the paper, whenever you insert all the elements, that is 10, 20, 30, 40, 50, 60, 70, like this. For example, this is your stack, and you have inserted 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. You have inserted, these are the elements. It means your top will be first minus 1. You are incrementing every time. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So your top is your index, and your index is managing all this number. Now I want to delete. It means whenever you want to pop, your top element should be deleted first. And whenever you want to delete the top element, what we can do? Very simple. We can first print the element, and that will be ARR of top. So whenever you write ARR of top, the top is 9, so it will print 100. Now we just need to do what? Top minus minus. Whenever you just decrement the top, so it will be automatically removed. So your array will become up to 10 to 90. So very simple. Whenever you are inserting the data, you can manage the top. And whenever you are deleting the data, you can just decrement the top. So the concept is what? Whenever you are pushing an element, just increment the top, and whenever you are deleting the element, just decrease the top. This is the simple logic. Now I want to pop the element, so I will use the case 2. What we will write in case 2? Simple. Percentage D is popped. It means this element is popped. Which element is popped? ARR of top. So if you are writing like this, then your top element will be definitely popped, but we need to write here top minus minus. Now might be a chance your top become minus 1, because if you are continuously popping the element, see, now my top become 8. Now suppose if I am dropping this, popping this particular element, then my top variable becomes 7. If I popping this, then my top becomes 6. If I remove all this, right, then my top become minus 1. It means if my top is minus 1, then we can say that stack is empty. So if top equal minus 1, then we can printf the stack is empty. So our stack will become empty whenever the top is equal to minus 1. And the same thing you can write in a case 3 also to display the data, that if top not equal to minus 1, and then try to display all these things. If top not equal to -1, then and then try to display this, else simply print the message that stack is empty. Why? Because whenever my top is -1, the stack is empty. You can just check. See, whenever you are running your program, your stack will be, your top will be -1. So if you write 3 option over here, it will give you a message stack is empty. Yes, it is correct. Now we are just trying to push the element. How many element? 3, 10, 20, 30. Display this. Now it will display 10, 20, 30. Right? Now try to pop. So I'm writing 2. So 30 will be popped. See, 30 is popped. And you can display the element. Now it will be only 10 and 20. Right? So it is working properly. Suppose if you are writing 2, then your 20 will be popped. Now your element is 10. Now you can push the element. How many element? 3. For example, 40, 50 and 60. Now you can check the display. So 10, 40, 50, 60 are there. Now let me pop each and every element. So 40 is popped. Now only one element is there. So pop the element. See, the 10 is popped and stack is empty. Now if you are trying to display the data, your stack is empty. But suppose might be a chance if you are continuously pushing the data, right? So if your top become, right, your top is -1, right? It's starting from -1. So if first element is there, so your top will be 0. Now if your top become 99, it means your index is starting from 0. So if top become 99 means it will reach to your size, that is array size is 100. So if top become 99, then you can simply print the message that stack is overflow. It means stack is full. Now you cannot insert any data into this stack. Now very simple operations are pending, that is case 4 and case 5. Very simple. Suppose if you want to do a case 4, that is peep. So peep means what? Which element you want. So you can write here the you can write the printf statement, enter which position you want. So which position data you want, you can ask for the position from the user, that enter the position. So POS, so which position you want, and that particular position you can print. Simple. %d position is equal to %d, and the position at this particular position value is available. So you can simply print here ARR of position. So now whenever you run this, definitely you need to declare the variable, and that will be your position. So which position you want the data. And whenever user says that I want to pick the data, pick means I want to pick the top element. So whenever you want to pick the top element, then you can write case 5 printf. You can directly print /n top of the stack is equal to %d, and you can print ARR of top. But you need to be careful over here. That is what, if top not equal to -1, then and then do this. It means top of the stack will work if and only if the stack is there. If stack is not there, then we don't want the top of the stack element. Now you can build and run. Now all the operation is worked properly. See, if you are trying to pushing the element, how many element? 3, 10, 20, 30. Display the same. 10, 20, 30 is there. Try to pop, 30 will be popped. Now 10 and 20 is there. Now try to push 3 more, that is 40, 50 and 60. Now get the display. So 10, 20, 40, 50, 60 is there. Now try to find the position, that is fourth option. Which position you want? I want the second position, that will be position is starting from 0. So it will give me 40. So second position is equal to 40. Now you can pop the data. So whenever you pop the data, your last element will be popped. So here you can check, see 10, 20, 40, 50 is there. So you can find the top of the element now. Suppose if you are writing 5, so top is equal to 50. Now if I am popping the element, now top will be 40. If I am popping the element, now top will be 20. If I am popping the element, now top will be 10. If I am popping the element, then the stack will be empty and there will be no output for the top. Why? Because my stack is empty. So this is the simple application of linear data structure. You can manage the stack. The concept of stack is what? That is last in, first out. So that's it from my side.